Okay, folks, we have reached the third question in our first question for the DBE, and that question is usually the question that asks you to solve a simultaneous equation. Let us start and see where do we begin, what it is that we need to do, and how we do that. Well, first of all, there's two types of equations. There's the linear equation, x plus y equals 3, and then there's an equation of higher order. So that means it's either a quadratic or a cubic. It could possibly be a hyperbola. In this case, it is a second degree equation in x and y. It reads 2x squared plus 4xy minus y equals 15. Okay, folks, so let's put down some tips for you to consider when you get a question that looks like this. First of all, you have a linear component over here. So the first thing that you would want to do is you would want to isolate one of the variables. Now you must check very carefully which one do you isolate. You choose the one with a 1 as a coefficient. That's very important, because if it doesn't have a 1 with a coefficient, then you are going to form unnecessary fractions. So, we are lucky this time around we have x plus y that is equal to 3. Okay, so I'm going to say let us then isolate the y. Let's say y is equal to 3 minus x. Okay, then the second thing we do is we number our equations. Okay, so I'm going to go straight for that. We number the first equation 1, and let's number the second equation with a 2. Then the equations are numbered. Okay, now you need to substitute. Substitute number 1 into number 2. Okay, let's see what that gives us. Now remember, I've made 1 equal to y equals 3 minus x. That goes into number 2. So everywhere where there's a y in the second equation, I substitute with y equals 3 minus x. So I get 2x squared plus 4x multiplied by that y minus the y, the second y over here, remember there's two y's, is equal to 15. And now I can start substitution. 3 minus x, and then also 3 minus x over here. Okay, so what's left for me now is to distribute the brackets. I start my distribution of my brackets here by saying I do not have anything connected to the 2x squared yet, but here I have 4x times 3, which is 12x. Then I have this 4x multiplied by minus x. Now be careful there, that's minus 4x squared. Folks, here I have a negative that distributes into both terms in the bracket. So I get minus 3 plus x. The 15 comes to the left. That leaves me with minus 15, and the result is indeed naught. Okay, so let me see where's my like terms. Here I have 2x squared. Then I have 4x over there. I have a 12x here and an x over there. And then I have the constant. So please make sure that you take care of the signs when you add these things. So I get 2x squared minus the 4x squared is indeed minus 2x squared. 12x plus x gives me 13x. Then I nearly did not see my 3 over there. Okay, so let me color it nicely so that we can see we have our 3. Don't forget the little 3, because that changes everything. Minus 3 minus 15 is minus 18, and that gives me a 0. Now, folks, you can see our leading term over here has got a negative 2 in front of it. We do not want negative in front of the leading term, so we change all the signs in this equation and we write it as 2x squared minus 13x plus 18, which is indeed 0. And now we've got to pause a bit. We have a constant of 18 and we have a leading term of 2. So this is a little bit more trickier, because now we need to deal with a leading term of 2. So we look for the factors of the constant. Let's go to our sketchboard and see how we do this. The factors of 18 is plus or minus 1 multiplied by plus or minus 18. Or it could be plus or minus 2 multiplied by plus or minus 9. The third factor pair is plus or minus 3 multiplied by plus or minus 6. So for 18, we really spoiled for choice. But poor old 2, it is a prime number, so it only has 2 factors. Now I've got to look at the factors of 18 and 2. I must choose one of the 3 combinations that I have for the 18 in connection with the 2, so that I can write down my final factor pair. Now remember, this is 1 that's multiplied by plus or minus 2. Now I'm sure if you look carefully here, you'll see that 2 times 6 is 12. And if I take 12 and I add 3, I am way above the 13 where I want to be. Now let's look at the signs then in the equation to determine what we want to do. First of all, the sign of the constant is a positive, and the sign of the constant being a positive means that the signs in the brackets are the same. In the brackets. Okay, so we've established they're the same. We look at the sign of what is in front of the middle term, and that is indeed a negative. So because they're the same, and we have a negative over here, it means both signs in my factor pair are negative, folks. Okay, so now I've got enough information. There's nothing else I can do with a 2 but 2x times 2, because it is prime. The signs are the same, they're both negative, would mean, remember, we chose the second factor pair, so we chose 9 times 2. They are both negative. Now let's see if we were correct. If we check going back, 2x times x is definitely 2x squared. Then minus 9 minus 2 is definitely positive 18, so we can tick them. Now for the middle term, here we have minus 9, and then the outer terms we have minus 4, and that is definitely minus 13. It's always worthwhile checking yourself, folks, because you should get full marks for the simultaneous equation. Okay, we're ready to solve. So this tells us that x is equal to minus 9 divided by 2, or then x will equal 2. Now we've got our 2x values. We now need to go and find the y values, so we plug them in. Y is equal to 3 minus 9 over 2, or for the second x, y is equal to 3 minus 2. And that is simply just 1. Let's fix that one. Finish with that. So the first factor pair xy, that's a solution, is going to be 2 and 1. Okay, the second one, I need an LCD of 2. So I've got to multiply this 3 with a 2, which is 6, minus the 9. The 9 is already over 2, and that gives me minus 3 over 2. So my second factor pair, xy, where these two curves will meet one another, is at the point where x is minus 9 over 2, and the y value is indeed minus 3 over 2. Okay, so folks, that's what this answer actually means. It's as if you had the graph of the first function and the second function, and I'm just going to draw any graph just to illustrate to you. Let's say the first function, the graph looked like that. For the second function, the graph looks like that. So we were finding the points where those two will intersect with one another. Now that's huge, because that is going to become very important when you do graphs. Okay, folks, that is the question for 6 marks. Work slowly so you do not make a silly mistake here.